Good morning all. Here's an Indramat Servo drive model DKC11.1-040-7-FW, and it runs that motor rough. We'll go and enable that drive to run and you'll see. Phew, that's nasty. We're going to have to go inside and see what our problem is. We're in. Now what we're going to look at is in the current sense feedback from the high voltage side to the low voltage side. We have optocouplers. They're isolated operational amplifiers. Part number HCPL7800. There's two of them. Right here they are. We're going to look on the output side, and it should be fairly smooth waveform. And let's take a look. So I go on pin 5 is the ground of the output side. These are differential outputs. Oh yeah, that looks bad. Let's go to pin 7. Yeah. There we go. That's bad. That one's going to have to get replaced. Let's check the next one. Oh, keep slipping off of that one. The green connector's in the way. There we go. Oh, that one's worse. That's horrible. Let me get you close to the oscilloscope so you can see what's going on. But that'll make that motor run rough. I've got my scope set to AC coupling, and that way the waveform will ride around this 0 volts right here. Otherwise, it would be way up here off of the screen, because it's a differential output. Each output rides about plus 2.5 volts thereabout. So I set the scope to AC coupling. And the reason I have to do that, because we're going to look at 100 millivolts per division. That's very tiny. Now just floating in the wind, you can see we're moving. So let's turn on our drive, and we will look at the waveform. And it is nasty. Let's go over here. Now I'm going to be slipping off of these pins. Here's pin 4 ground. Let's get on there. Here's pin 5. That's a differential output, one of the outputs. Look at that. Look how nasty that looks. Okay, that was pin 6. Here's pin 7. And all that jitter from the feedback causes that output to run rough. Now let's go over to the next one. There's the second HCPL7800, and that's worse. Look at that. That is horrible. That's pin 5. Or I'm sorry, that's pin 6. Here's pin 7. That's the second differential output. You have an out plus and an out minus on that IC, as well as an in plus and an in minus. Huh. That's terrible. We're going to have to change those ICs. They fail, just like everything else. They fail. Let's see what we got now. We got everybody hooked up. Let's turn on the control voltage. Comes up to BB. Let's turn on the 380 volts AC 3-phase. Goes from BB to AB. So far, so good. Look at that. HCPL 7800. Those were the problem. We're running now. All right, all. You fixed another one. Good job. Let's see what it looks like now after we've replaced the HCPL 7800s. There's pin 6 of the first IC. There's pin 7 of the first isolated operational amplifier. That looks much better. Here is the second isolated operational amplifier, pin 6. Much better. There's pin 7. Oh, slipped off the ground. There we go. There's pin 7. Not as jittery. Much better. Okay. Hello all! Here we're going to discuss the hookups to make that Indramat Eco Drive run. Model number DKC11.1-040-7-FW, that servo drive. We have on terminal E1 and E2 of the X3 connector. That's our speed reference input. I have plus and minus 10 volts DC from an external power supply and its ground. The plus and minus 10 volts go to the wing of this potentiometer. And the wiper goes to X3 pin 1, that is E1. The ground of this power supply goes to pin 2, that is our E2 terminal. Now we can control speed and direction with this potentiometer right here. Now my potentiometer was 10 kilo ohms. To start and stop the servo motor, we have two switch inputs. One labeled RF on terminal 2, and the second switch input labeled AH/start on terminal 3 of the X4 connector. From an external power supply, we have 24 volts DC and its ground. The positive 24 volts DC goes to pin 1 of the X4 connector. And the ground, not the same ground as our speed reference, separate ground, goes to pin 4 of X4. Now 1, 2, and 3 are on the left side of the drive, and 4, 5, and 6 are on the right side of the drive. So when we close the RF switch, that puts that servo motor into holding torque. And when we close the AH start switch, that motor runs. Down here is the thermal input on X6, pins 1 and 2. We have to jump that thermal so we don't get a motor thermal alarm. That's TM plus on X6 pin 1 and TM minus on X6 pin 2, terminals 1 and 2. Jump those together to simulate that motor thermal. Now let's look at the power connections. The Indramat servo motor is connected to A1, A2, and A3 of the X7 terminals. And frame ground connected to this terminal right here. Now I applied, to power up that drive, I applied 380 volts AC 3-phase to L1, L2, and L3 on the XA connector. Those are our power connections. Now if you want to look at the DC bus voltage, let's go look at the X9 connector. On the X9 connector, you can measure the DC bus voltage. On L plus 1 and L plus 2, that's your positive DC bus voltage output. On L minus 1 and L minus 2, that's your bus ground. So you could put your meter on these terminals and measure the DC bus voltage. There you go. That's all the hookups right there to make that drive get up and go. Awesome. All right, folks. Have a good evening. We're going to cook us some cornbread. Let me show you that cornbread I'm going to cook. Hold on a sec. Don't move. Box, come here. Come here, Box. Got me some of this cornbread right here. And that is Famous Dave's original recipe cornbread mix. Legendary restaurant favorite. Shoo-wee. That's gonna be good. That's gonna be good right there. Hope I got all the ingredients to cook that cornbread. Looks like I might. Let's see what we got here. We gotta have a 1/3 cup of milk, a 1/3 cup of water, and 1 egg, and plus the mix. I think I could make that tonight. Alright. If y'all want some cornbread, go out and get you some of that. There's all your hookups right there. That's all you need. Good night, everyone. Have a good day. Have a good life. We'll see you next time.